Statistics lesson 6.2, real applications of the normal distribution. 3 objectives. Develop the ability to describe a normal distribution, not necessarily a standard normal distribution. Find the probability of some range of values in a normal distribution. Find x-scores corresponding to regions under the curve representing a normal distribution. Now we will convert from a non-standard to a standard normal distribution. And we do this through z-scores. Z equals x minus mu divided by sigma. Okay? In other words, x minus the mean divided by the standard deviation. Procedure for finding areas with a non-standard normal distribution. Sketch a normal curve. Label the mean and any specific x values, then shade the region representing the desired probability. For each relevant value x that is a boundary for the shaded region, convert that value to an equivalent z-score, and then find the area of the shaded region. So that's the procedure we're going to use for finding. Here is an example. Heights of men are normally distributed with a mean of 68.6 inches and a standard deviation of 2.8 inches. Find the percentage of men who are taller than a showerhead at 72 inches. Okay, so here we go. Here is our non-standard. That's our non-standard. Our mean here is 68.6 inches. Okay. Now 72 inches. Let's see. Let's take 68.6. 68.6 plus, and I think it was 2.8 inches. 2.8, and that's going to be 71.4. All right. So one standard deviation going to be over here. One standard deviation is going to be, what was that? 71.4. 71.4. Well, we're going to go 72 here, right? So we're going to go a little bit further. We're going to go a little bit further here, and we'll say it's like right there. All right. We're going to say this is 72 inches, all right? And the heights of men are normally certain. Find the percentage of men who are taller than a showerhead. So we want to find this area over here, okay? We want to find that area right there. Well, let's go to a standard normal, okay? And then remember, that's got a mean, and that's a little bit off. Let's see if I can do better now. That is, now I know this looks like a lot of work right now, but I'm trying to show you something, okay? So bear with me a little bit. It's actually a whole lot easier than this. Now, that was z equals x minus mu divided by sigma. Okay, so in this case here, that's going to be 72 minus 68.6 divided by 2.8, and that's going to standardize it. So let's try that. Let's see here. Control, divide, and we got 72 minus 68.6 divided by 72, and that's 68 minus divided by, oh, that's not supposed to be 72, it's supposed to be 2.8. 2.8. All right, that's 1.21. 1.21. So we got some, we're looking for some over here, and we're going to say this is 1.21. And we're looking for this area over here. All right, good. Now let's 1.21. Let's go to our table. Let's go to our table. Negative z-scores. 1.21, so we need to be on the positive table. 1.21, so let's blow that up some. And 1.21 is going to be 1.21. It's going to be 0.8869. Yeah, 1.8869. So this area over here is 0.8869. So we're going to say, we're going to say 1 minus 0.8869, and that's going to give us this area over here. 1 minus 0.8869, and that's 0.1131. Okay, that's 0.1131. So this area here is 0.1131. So basically 11% of the men are taller than 72 inches. Okay? Now we could have done it with a calculator. Remember, menu 552. Lower bound would have been 1.21. Upper bound would have been positive infinity, 0, 1. And that gives us 11.1131. 0.1131. All right, that was pretty darn close. Now, with technology, we don't have to go to all that trouble. Okay, we don't have to go to all that trouble. This is how we use the z-score, and you can use the z-score and the z-table to do it. But if you have the right calculator, you can just find this area right here real quick and in a hurry. I'll show you how to do that. We're going to go back here, menu 552. Our lower bound is going to be 72. Our upper bound is going to be positive infinity, 999. Our mean is 68.6. Our standard deviation is 2.8. Press enter. 0.1123. So with technology, we're a little bit more precise. Okay. So with technology, we find it as 0.1123. Okay. So I showed you a couple of ways. One, convert to the Z, look up on the table and find it that way. Or just using technology, you can go straight to it. Oh. The U.S. Air Force requires that pilots have heights between 64 inches and 74 inches. Heights of women are normally distributed with a mean at 63.7 and a standard deviation of 2.9. What percentage of women meet that requirement? All right. Let's see here. Let's find, we're going to do, so the women's mean height is 63.7. 63.7. Okay. And the pilot, let's see here. The Air Force requires pilots have heights between, it says between 64 and 77. Okay. So let's see here. We need to find this area 64, and that's probably going to be real close to 77, and that's going to be maybe over here somewhere. Okay, and I'm not exactly sure because so we got 64 to 77. Okay. All right. Well, first let's do it the Z method. Let's do the Z method. So we have over here, we have 0, a little off. We have 0, still off. And there we go. All right. We have a mean of 0. Mean of 0. And so we would have to convert all of these over. Okay, so let's see here. Z would be 64 minus 63.7 divided by 2.9. Okay, so let's try that. 60, let's control divide. So we've got 64 minus, and what was it again? 63.7. 63.7 divided by, and we had 2.9. 2.9. All right, and so that's going to give us 0.1. Okay, so let's see, we got 0.1, and that's going to be real close, like before. So that's going to be, and we're going to call this 0.1. 0.103, 0.103. Okay, and now that we got to find the Z for 77. Okay, so we got 77 minus 63.7 divided by 2.9. 77. I'm just going to go up there and grab that and change that 64 to 77. 77. And I got 4.586. So I put that line right there. It's actually much further to the right. Okay. Matter of fact, it's more than that. It's out here. Okay, so we got, we said it was 4.586. 4.586. Okay. So we want to find it out here. While I'm at it, I'm gonna go ahead and fix that one there, because that needed to be over here as well. Okay, well, that needed to be right there. All right. So here we go. So what we're going to do is we're going to find between 4.586 and 0.103, and we'll go menu 552. Our lower bound is 0.103. Our upper bound is 586? 586. 586. 0. And that gives us 0.45. Okay? 0.4589. 0.4589. So that gives us 0.4589. So basically, only 46% of the women fall in that category. Okay. Now, can we do the same thing here using these numbers? We can. Menu 552. Our lower bound is going to be what is it? It was 64 to 77. 64 to 77. And we had a mean of 63.7. 63.7. Standard deviation was 2.9. 2.9. 2.9. And that gives us 0.4588. All right, and that's the difference between these two is the rounding right there, because this didn't do any rounding. So we got 0.4588. 0.4588. Okay? So there we go. That's how to find the shaded region in here. Okay. I showed you two ways. One, using z-values, and two, just using technology. Okay, just using technology. And I must have knocked that down again. All right. Finding values from known areas. Graphs are extremely helpful in visualizing, understanding, and successfully working with normal probability distributions, so they should always be used. Don't confuse z-scores and areas. And let me show you what I'm talking about. Okay, this right here is a z-score. This here is an area. Don't confuse those two. All right, and that's a z-score. Okay. Z-scores, and this here is area. Don't confuse those two. Choosing the correct right or left side of the graph. Remember that when you're using the table, it works from left to right. Okay. A z-score must be negative whenever it is located in the left half of the normal distribution. Areas or probabilities are always between 0 and 1, and they are negative, never negative. Okay? Never negative. Procedure for finding values from known areas or probabilities. So the thing to do is sketch a normal curve. Write the given probability or percentage in the appropriate region of the graph, and identify the x value or values being sought. Okay, and let me give you an example of that. Here's one. When designing equipment, one common criteria is to use a design that accommodates 95% of the population. In example 2, we saw that only 46% of women satisfy the height requirements for U.S. Air Force pilots. What would be the maximum acceptable height of a woman if the requirements were changed to allow the shortest 95% of women to be pilots? Okay? The shortest 90%. So we're going to do the shortest 95%. And so we're going to draw something right here. Okay, and the shortest 95% would be over here. Okay, that would be the shortest 95%. In other words, we're going to find the 95th percentile height of women. Okay, what was our mean? Our mean here was 63.7 inches, I believe. And we had a standard, let's see, our mean was 63.7, and our standard deviation was 2.9. So let's go back, and this time we're just going to use technology. Menu. 553. Our area is 0.95. Our mean was 63.7. Our standard deviation was 2.9. And that gave us 68.47. 68.47 inches, okay? That would get 95% of the women would meet the height requirement then, okay? Significance. Probabilities can be used to determine whether values are significantly high or significantly low. Significantly high. The value is significantly high if the probability of X or greater is less than or equal to 0.05. or sometimes you might use an alpha of 0.01. Significantly low, the value is significantly low if P of X or less is less than or equal to 0.5 or 0.01. All right, so let me kind of show you how that works. And didn't mean to do that. Let's use, here we got an example here. And this will be pulse rates, okay? Pulse rates of women. And let's see, women's pulse rates had a mean of 74 beats per minute, with a standard deviation of 12.5. I don't know why I wrote it like that. 12.5 beats per minute. All right, so we got that. What we want to do is we want to see what would be significantly high or significantly low. Okay, and let's see. We'll use let me draw a thing here. I got to cover over. I wanted white. And let's see here. There we go. Let's see. I'm going to draw a standard normal curve here. And let's make that black. I don't do these very well freehand, so we're just going to wow, that's one of my better ones. You're welcome. All right, so we got right here in the middle, we have 74 beats per minute. 74 beats per minute. We want to find over here. We use red, and then over here we want to find. And this is 0.05, and this is 0.05. Okay, so we want to find these two areas over here. Well, we need to find what these numbers are. Okay, and we'll go into our calculator. Menu 553. Our area is 0.05. Our mean was 74, and our beats per minute was 12.5. That was our standard deviation. And we got 53.44 beats. 53.44 beats. 53.44. Now we want to find this area here to the right. Okay. Well, if this is 0.05, this hole right here is going to be, this point here is going to be 0.95. Okay, so that's what we're going to have to use in our calculator. Menu 553 and then 0.95. And again, it was 74 and 12.5. And that's going to be 94.56. 94.56. Okay. So our leftmost value is 53.4. Our rightmost value is 94.6. So it is, your heart rate is significantly low if it is below 53.4, and it is significantly high if it's above 94.6, okay, if we just got, all right. And then if you went to the doctor and they took your heart rate and it was, say, 96, they would be concerned. That would be considered significantly high. All right, folks, great job. See you tomorrow and have a wonderful evening.